afternoon I'm going to be speaking about standing condition predominantly in Barmah and the Millewa Forest, but also the implications for birds. So I've had a fair bit of background from all the talks, but I'd just like to reinforce what the ecological problem is. So basically, I'll come to this slide, but this is a good condition forest, and that's how we'd like to see red-gum forest. But unfortunately, across the Murray system, there's a lot of stands that look like this, where trees have lost at least half their canopy. Not something you'd want in your backyard. But even worse, you have essentially collections of dead trees along creek lines. So this is a serious problem. And we all know what it is. The problem is lack of water. So when I came into this area of research in 2006, the main thing I was sort of aimed to do was create a quantitative map of condition across the whole Murray system. Because although we all could go out there and see it, we didn't really know what the full extent was and where it was, and then we could start targeting our management. So how do you do this? Well, essentially we did ground surveys of stands across the whole area. In the first survey we did 140, and now for the TLM process every year 175 sites are resurveyed. Then you get environmental variables that have a coverage across the whole floodplain, predominantly satellite data. Create a model, so get a model that can predict what you measure on the ground from the remote sense data, and then you can predict across the whole floodplain. So it takes you that leap from the traditional sort of ground survey where you've just got point data and you say, oh, the average in this forest was this, to actually knowing what it is across the whole system. But, you know, we all have sort of reservations about models. And when you really get to believe is when you validate. So what I mean by validate is you make predictions for your model across the whole landscape, and then you go to areas of predicted condition, and you see what it actually is there. And if that works out well, you create a map. So what do I mean by stand condition? Because I think it's good to get you sort of understanding what I mean, because people condition means so many things. Really, I'm talking about the amount of canopy that the forest or stand has relative to what it should have. And we measure this using 3 variables. So crown was now called crown extent, but I'll put that on the slide there. And that's the amount of crown an individual tree has relative to what it should have based on the existing branching structure. So what's left. And you can see I've drawn a little dotted line around where it should be, and you can see there's a lot of that's missing. Then we measure a plant area index, which is based on these artistic hemispherical photos, and that's essentially a measure of the canopy in that stand. And then the final one is live basal area. So the amount of trees that are actually alive and a measure of mortality. Package these all up into a stand condition score which has a maximum of 10. So what does this stand condition actually look like on the ground? And generally for managers and that, I put it into a stand condition scale. So the top class is called good condition, and that's a score of 8 to 10. So essentially your average tree's got at least 80% of its canopy that should have. There's really not many dead trees there. So that's good. Then when you go down below an 8, anything below that is considered forest dieback. So in the first one, the moderate one, your average tree would have lost about 25% of its canopy. So you wouldn't be happy about that if that was in your backyard. And so on and so forth till you get down to the lowest one called severely degraded, and you'd be lucky to find a leaf on a tree and then essentially a dead stand. So I decided not to go into too much detail with the modelling, but to focus on the part of the belief. So we have a strong model or many models that can predict what we surveyed from the remote sensing data. But what this graph shows is actually, this is what the model predicts for areas, and then we went out and surveyed new areas. So we went out and surveyed, in this case in 2012, 50 new stands ranging from the Middle Murray around Barmah all the way up to Lindsay Moore Pollard. And as you can see, this is sort of one of those, not eureka moments, but exciting moments, at least for me. This thing works. So you can see there's pretty much a strong, almost a one-to-one relationship between what we're measuring on the ground and what the model is predicting in areas that the model wasn't actually built on. So that's when I get faith in these actual maps being useful. So it's all predominantly about mapping, and I'm sure you're familiar with this shape. It's a Barmah-Millewa Forest. So I'm not focusing one bit, I just do it all, you know, ambitious. So as I said, I started in 2006, so sort of mid-drought, and at that stage, I'll sort of walk through this map slide. The dark green is the good condition forest. So in 2006, there was only 30% of that forest was in good condition. So that's not a good thing. That's like 70% of that forest had dieback. So predominantly in Barmah-Millewa, it's in the moderate class. So it's not going to die the next day. But predominantly there's dieback right across, and there's very small areas in bad condition. The next thing we did, I'm going to step back in time, and we used the model. So one of our models, and gave it 2003 Landsat data or satellite data, and saw what it predicted for what was going on in the past. And the first thing you'll see, and then if we go backwards and forwards, a massive amount more green, good condition forest. So in 2003, only 3 years before there, the model's predicting that about 50% of the forest was in good condition. 50% was in that other light green moderate condition. So it's quite a quick shift in condition. And no big surprises, there's no water on the floodplain over those years. Except in, and that's the other feature I probably haven't focused on, we'll go to the next slide. From 2009, moving forwards into the drought, is now you've only got a 20% good condition forest, and this is focused along areas that get water. So along the Murray River Channel, so I've got the direct rivers into, along permanent creek lines, and then in some wetlands that may have received environmental flows as well. And you might see this glaring little patch here, saying that was a bit of a hot area. There was a fire up there in the Morris State Forest. So we pick up all facets of bad condition. We're not judgmental. Yes, we are. And then moving forward to 2010 on, and I may clarify this is summer 2010, so before any rain or above average rainfall or any flooding. And you see the condition, good conditions gone down a bit more, 8.5%, and then you're starting to get 15% of these yellow core areas, probably a bit more on the Kundruk side, and that's not because New South Wales does bad things, it's just higher country. So there we are, sort of at the end of the drought, looking pretty bad. So now we're thinking, and this is where we're all waiting. So we're going to get the floods and above average rainfall is going to come and save us, or save our forest. So 2012, summer 2012, you ignore the fire patch there. We did get a kick up, so you got 23% of good condition forest. Not a massive improvement, like not biblical change or anything like that, but certainly you've stopped the downhill and you're starting to pick up again. So just to give you, sort of summarise that sequence of events, the temporal sequence, you started up in 2003 with 50% good forest, and then you've got quite a steep decline in 2006, getting down around about 30%, and then towards the end of the drought, you sit here at the 20% mark, and the recent floods seem to have not made a huge change in condition across these forests. And there's a possibility, we've got people surveying out there, that 2013 might be a slow crawl up. Because if you've been hit by a 10-odd-year drought, you're coming from fairly low baselines of trees, so recovery's not going to be that rapid. So the next thing we did, and we've done two things, is we're interested to know, is this assessment of stand condition, which is obviously successful and fairly robust and quantitative across large areas, can it be used to predict biodiversity more broadly? So we've done both, looked at how it relates to understory vegetation and also birds, which I'll focus on today. And what we did is we did a survey of 45 sites across both Goulburn and Barmah this time. We assessed stand conditions at the sites, so not predicted condition, just actual on-site condition. We surveyed these 5 times over the 2009 breeding season, and we calculated these 3 things. So utilisation intensity, which basically means just the total number of birds you recorded over the survey. Species richness, so the total number of bird species you saw over that period. And then breeding score, which goes basically between seeing a male and a female together, so possible breeding pair, all the way up to seeing actual young being fed out of the nest. So essentially successful breeding. And what we did is we looked at modelling this at various habitat variables, including things like coarse woody debris and that sort of thing. What we found was the strongest predictors of these 3 bird responses was stand condition and also basal area of dead trees. It was a good predictor of how many birds were there, how many species were there, and also the success of breeding. So quite a strong relationship between what we could map across the whole forest and what the birds were doing. And it makes sense that as condition goes up, you've got more leaves, you've got more resources and leaves, and as basal area of dead trees goes up, if that's married together with good addition forest, it basically means you've got an old dead tree with hollows and more habitat. So I've summarised the implications of this work in this visual slide. I started off just to do point forms, and it may be a little bit doom and gloom, and worst case scenario. But at the moment we've just been through a long drought period, the millennial, the big dry, followed by what's looking like a short wet period, if you believe in the flip in rainfall since last spring. And this is certainly what all the climate predictions are for southeastern Australia, is that we're going to see more long dry sequences followed by wet sequences. So what do we see in the recent sequence? And we saw during the drought, from my work, the standing condition was going down, 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 and during the wet period we'll have a little peak up. If we go on another drought, it's going to probably go down, 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 get a little bit peak up. Now what are the birds going to do there? Well, I'm not a great zoologist, but that's a tree creeper, so a lovely floodplain bird. You start off with a fauna that has those, and as your standing conditions going down, you might have a pair of galahs sitting there on a dead branch. So that's how I like to end there with that cheery note. But also, I suppose something I did miss you pointing out is the areas that are actually getting water, so ones that are either getting environmental flows or in the lower part of the landscape, so essentially red gum forests versus woodlands, they did show a reasonable increase in condition because they're getting water. So it really is just down to that good old thing in floodplains, that if a floodplain gets the water that it needs, it will improve. It's just about getting more water to more of the floodplain. Thank you.